My name is Allan, and this is a picture of somebody trying to do DevOps. The latter is the DevOps, and I think I've seen this many places that it's really hard. You have a lot of resources, but just getting that ladder put the right way up and actually getting forward can be very difficult. So I don't claim to have invented the ladder or invented all this DevOpsy stuff. I've done some small contributions, but they're very small. The only thing I can do is, turn this ladder right side up and climb up it. And that I'm pretty good at. Although, to me, sometimes the ladder seems more like this. It just keeps going on and on forever into the sky, and the steps can be really hard. And as someone who is afraid of heights, this is sometimes a difficult journey. So I want to give you a bit of context. My talks are always just stories from practical experiences. So it's not based on research, although I've done some of that. But I'm just sharing some stories. And when I share stories, I think it's important that you get the context in which they were created, these stories. So you can say, well, that was just Allan's situation. This doesn't apply to me at all, and feel good about that. So I'm not here to tell you what to do. That's very important. I do hope I can inspire you, and the context is, as I said, important. So I'll just spend a little time on the context in which I've worked for 8 years with DevOps in different companies. So this is not just one company. I've been several places. And this is kind of a bouillon soup boiled from that. So the product I've always worked on, web-based HTML, CSS, JavaScript with REST APIs, JSON, REST APIs, and a little bit of mobile. Simple stuff, really. The size of the product, well, we had some websites with millions and millions of users, but those are not really interesting because they are so easy to scale, and it's kind of a solved problem to make that stuff just work, especially when they're very static like the stuff we had. I'm talking about the product itself, up to about 200 servers, millions of API requests per day, up to 20 developers, and up to 5 platform and operations people. So this is the kind of size I'm talking about when I'm telling my stories. And I think hearing stories about GitHub and Amazon and Spotify and all those stories are super great. Sometimes I myself think I feel very inspired, but I don't have the resources to do all those crazy things they're doing sometimes. So this is kind of a different context with a small-sized company. So I hope you can use that. System sensitivity to bugs. So the stuff I've been working on, you really don't want to have bugs in it. Bugs can potentially have high monetary impact, or even patients' safety can be at risk. So yeah. Pretty high tolerance to bugs, or not tolerance. 5-minute downtime is not really a problem in the things I've worked on. So, I mean, of course you don't want it, but nobody dies. It's not a phone system where you can't call the emergency services and somebody risks their lives with the stuff I've been working on. 5 minutes is it can happen. Complexity, somewhere in the middle. I mean, it's not a space rocket, it's not a simple website, pretty standard stuff. So that was the context I'm telling stories from. Then I think it's we have these talks here where sometimes we go into nitty-gritty details about different things people are doing. I think it's worth to have just the DevOps high-level stuff in one slide. So for me, you got to remember that all of this is to optimize the value stream, actually taking an idea and turning it into value for your customers, in the hands of your customers. So you do that by optimizing flow, states, making work visible, working in small batch sizes, building quality into the process so you don't have all these gates and stops, and continuous optimization, but towards global goals, not just one team running really well. Yeah, tech is doing awesome, yeah, but the business can't get anything done. So you got to optimize for global goals and feedback loops that you continually improve and enhance as you get better and better. And you need those feedback loops in all parts of the value stream. And the feedback needs to be fast and continuous. When you see a problem, you swarm around it and fix it, kind of the Toyota thing. And then learning as part of the culture, having a trust culture where somebody dares speak up when they make a mistake, as we heard, is important. And having a scientific approach to experimentation, do lots of experiments, and also to the risks you're taking. So that was just my DevOps in one slide. Now over to some real stories of the ops and DevOps. And this has been a challenge to myself to try and come up with these, because I always talk about the dev part of the DevOps. So these are just stories about the actual ops we've been doing for the last 8 years, the various places I've worked. So the first thing is, of course, you need to be able to restart servers by the push of a button. This becomes a building block in so many things that I'm going to talk about later. So having some way where you can spin up new servers, add them to the load balancer, and take down the old servers and automatically have that happen just at the push of a button. So hands up, anybody here who has that for all their web servers? Automatic restart? Okay, just 5 people. Okay, I thought that would be many more. So, I mean, we actually also have it for the databases, where you can do the failover, primary, secondary failover, and have the databases restart. I haven't actually restarted the database ever, but you're going to need it for some other things later, that you have that capability. And the way we've done this is you don't need to coordinate with developers. When you're restarting some servers as an ops person, you just push the button. You don't need to tell anybody, because the system is built to handle that. That's kind of a building block you need. Then, of course, patching the servers becomes easy, because you just use the restart mechanism, and instead of spinning up the same servers, you spin up a patched server. Again, with no coordination with the developers. Scaling servers, I mean, this is from Amazon Lambda, where you just scale a slider, Heroku, where you scale sliders. Also for the database part, if you need a bigger instance of your database, you just click some buttons and self-service these things, and you get bigger instances. Because of the building blocks I mentioned in the beginning, where you can kind of bring things up and down in a completely automated, coordinated manner, you get this capability of being able to do these kind of things by just the push of a button, and it actually automatically works. Does anybody have this kind of capability today? Okay, about 3 people, I think. Okay, so this is everyday life for us, and has been for many years the way we've worked with the ops in the DevOps. So I'm hoping you're feeling inspired, maybe. That's my hope, that this is actually possible, and with the size of the team that I mentioned. Now, provisioning new servers, I have an example where we released a new feature on our API, which became very, very popular with especially one user. And he hammered our API like you wouldn't believe, in a way that it impacted performance of the rest of the users. We actually had to provision a Redis, which is like shared state across the web servers, and take an open source module and have some rate limiting on the API to just shut him out of doing his crazy stuff. We were able to do that by just pushing a button with a supply we already had, getting a Redis instance up and running, and deploying this fix in a couple of hours. The story is not so much about API rate limiting. The story is about, when you need something, a new part of your technology stack, having the ability to just click a button and have it provisioned, and it's being serviced by some of the world's best Redis experts in the world. They're the ones who give you the operations for it. That's also been everyday life for us. So deploying, you have all your code as code, but you also have all your infrastructure and your configuration of all the modules you're using. All of that is in code under version control. And then whenever you want to deploy something, it runs through the automated test suite and then gets automatically deployed. And there's only one way to production. That's through the automated test suite, so you're always running stuff that has actually been tested. This is also something, automatic deploy. it needs the building block from the beginning of being able to spin up servers and run a new version of on the new stuff, and then you can get to a situation where you just push a button to deploy. Does anybody have this kind of automated deploy? Okay, more people. So how do you do that without having the ability to switch servers? Okay, so maybe some of you have it without knowing it. I'm guessing there were about 10 people who have this capability. Very important building block for the operations. Rolling back, some of the stuff we're using actually has a button where you can just click roll back to here, and then it, like within minutes, rolls back to a previous state. Usually you don't want that, you want to roll forward. But to be honest, in an emergency, sometimes it has happened, especially if your deploy system breaks right after you deployed and something goes wrong with your supplier's deploy system, or you did something wrong yourself. It's nice to have the ability to just quickly roll back. And again, at a push of a button, using the building blocks I mentioned earlier. So updating a framework, here I'm talking about updating Node.js on all your 50 microservices servers. The framework version, the Node.js version, is under version control, is part of your configuration. You can, what we've done several times is if you do a script that goes and looks at all your repositories on GitHub through the API and automatically pushes the change of the version of the framework, then you have the automated deploy system that will kick in, run all the tests, and deploy all of these new versions. This kind of thing is very nice if there's a security update on Node.js where you need to bump the patch version maybe, to just roll it out all across everywhere using Node, and then you have the new version. If you have these things as code and as under version control and behind an API, being able to script these kind of things makes managing tons of microservices a lot easier. So in this way, we have sometimes had like over 200 deploys in a day of all these microservices. The same thing if you're using some kind of open source module or some kind of package system. You use the same procedure for patching. If there's a security announcement on one of the packages you're using, you can roll this out across everywhere you're using that particular package. And you can script your way through it. That's the way to do it if you have good DevOps. In the DevOps handbook, there's an example of the PCI data breach investigation report of 2014, where they analyzed over 85,000 data breaches and 10 already known problems, already known vulnerabilities accounted for 97% of all the credit card breaches. 97% of the 85,000 breaches were caused by unpatched systems. Patching your systems is super important for security. And if you're doing a microservices architecture, you can guess where the next slides might go. This becomes more difficult. 8 of the problems were known, for over 10 years. That's just lazy. Or somebody lost track of what's going on in their systems. They don't have the full picture of what's going on. Something's just running. Nobody's ever looking at it. And then there's a vulnerability. So this, of course, speaks to the fact that if you have the configuration of the system so you can machine read it and analyze it in code, you're in a good place, right? So if you look at microservices, I love microservices. They are so awesome in the things they give us, but they also have some drawbacks. Things become more complex as you separate things out in some ways. And one particular way, I hope you can see, is they fragment and spread the configuration of your system if they are not all identically configured. And if you're doing tons of microservices, especially if you're doing it with different tech stacks on these things, for each tech stack, you need a way to analyze the packages used. It becomes a harder and harder problem the more diverse your tech stack is. So I think when somebody wants to introduce a new tech stack, a new programming language or something, they have to have an answer to the question, how are you going to keep that system patched? it has to be part of the solution if you want to take security and operations seriously. So I've solved, in my practices, I've solved this by just having Node.js as the only backend thing. It works really well, and it's all in package JSON. If you have Heroku or Amazon Lambdas, you don't have to worry about the actual operating system patching. That's taken care of you for you. But there's still a lot of patching going on with the packages. And I'm not saying you need to do just one backend technology. Just be careful that you need to have a way to solve this issue. In order to be able to do this automatic rolling out that you have scripted everywhere, you need to trust your test on every single service to a level where you think, if the tests are green, I actually dare deploy this to production. Otherwise, when you want to bump that framework version, you're going to have a ton of automated testing all over the place. This, of course, needs also high code coverage. That's the only way you can trust the tests. And again, the goal of this is to do these bumps, these patches, these updates without involving the developers, and it even goes to production without involving the developers. Or at least that's been our goal. And we've done it many times. I've done this for years. Some people, I haven't done this myself, I've seen some people actually do it automatically, some of this stuff, where once a week it patches automatically. I've also heard stories about that could go a bit wrong sometimes. But I mean, it's a possibility depending on your setup and how confident you are in your test. It's a possibility. So another thing from ops is like queues backing up. Your queue is running full, you're getting alarms. Potentially ops can restart the server, and sometimes that can happen. That can help, and then the problem goes away. But in my experience, if a queue is backing up, you usually need a developer with the domain knowledge of what exactly is going on. And the developers should hear these queue alarms, in my experience, and react to them. Performance tuning in the database, this is where you can really say, oh, that's just you, Allan. That's not at all how our system works. 6 years we had a deploy, and it happened twice in 6 years that we had a deploy and the system was slow. And then we went into the auto-suggested indexes and clicked OK, and then the problem was gone. That has been my level of DBA needed for the stuff we're doing. That, of course, means, I had an experienced team, and I can come up with all kinds of reasons for why that is. I'm just telling you the story that this can actually be a situation for somebody with the context I gave you. Migrating data model is something. There's going to be a talk later where you're going to get a lot of detail about how to do zero downtime migrations. We did them a lot also, and I just have 2 small slides about how we do it. You deploy some new code. You have a new and old data format. The new code reads the old and the new format, but only writes the new format. And with a schemaless database as we're using, the old and new format can just live side by side. So that's a prerequisite to do it this way. Then you patch the database, everything is in new format, and then you remove the code that reads the old format. Then you're done. We've done that many, many, many times. It's not that hard. Of course, requires a schemaless database. Sometimes, when you want to do a remodel of your database, it can be in a very complex part of the application with some pretty heavy logic around it. So it can be almost impossible to have the old version and the new version living side by side and handling that problem. And with our configuration, where we have tens of thousands of paying users, a lot of users, where each person doesn't have a terabyte of data, they just have much less data. We were able to do this kind of solution where you write the code so it only works in the new format. So you just write the code as if it's the new format. And then you write a piece of code that also, as a user logs in, just patches the data. Then they have to wait 15, 30 seconds, and then they can get to the system. And anyone who logs in this window will just get their data patched on the fly. And while that code is active, you actually go in and run the 2-hour, 5-hour job that actually patches all the data. And then once you're done with that, you remove the code that patches the user's data as they log in. We did that a few times with some very complex data migrations. Of course, you need to know the context. Lots of users. You can't do this if you just have 5 users who have terabytes of data. But with our system, that was a solution. Migrating database provider. So we grew unhappy, is maybe the word, with one of our suppliers. So the way we did that was spin up a completely new cluster, and then we had the primary to primary replication going on. So you have 2 live databases, and then you programmatically switch all the connection strings to the new one, and then you shut down the old one. It took about a day or so to get that up and running. So operations, we have around 200 servers, millions of API requests today, and historically the uptime of the systems I've been working on have been around 99.99% over the years. So how big is operations in this kind of setup? I said that we had 5 operations and platform people. That was in the very beginning. Then there was a company fission of the company where we lost the platform people, and we were left in a situation where we had to decide, do we want to build up that capacity again and use this bespoke stuff they built for our platform, or do we want to just take cloud stuff off the shelf and move to that? And we moved to that, which means that operations in the context I mentioned is handled by the developers. And 95% of the ops work, like having things come in for production you need to react to, is something only a developer, in my experience, can handle. Because it needs domain knowledge, it needs programming changes. Very, very, very few times is that actually necessary to have an actual ops person. And for those special cases, we have suppliers who are the world's best at MongoDB, who are the world's best at Redis, and whatever components we're using, and we use their support. So there's no room for a full-time employee. And if we did have a full-time employee, that person would never be as expert as the people we actually use for our operations. So no operations people employed. So summing up, I hope you can see there are very, very clear contracts between operations and developers, like operations as a service. Everything you do is almost self-service, everything. And this easy ops has to be built into both the architecture and the tech stack by not choosing a completely random tech stack all over the place. You can't do some of these things. So it's kind of built into the systems that you have these abilities to roll new things out, and you don't have any holy cow servers that have to be up. Developers in very close contact with operations. I mean, the alarms and the feedbacks you get from operations, error logs and things like that. And then everything as code, everything under version control. And a very important thing that I haven't touched on here, but I think is worth mentioning again, that I also mentioned last year, is this continuous improvement where you have really good retrospectives and blameless postmortems. So hopefully with that, we can all climb the ladder successfully into the cloud. That was it.